Hello everyone, a very good evening. So before we start the session, first let me know if I'm perfectly visible and audible to everyone out there or not. Quickly, you can write in the comment section below and I'll understand. Yes. We have Srinija here, Aditi Datta, hi ma'am, Chitra Moni, Adhira, hello ma'am, how are you? Hello Adhira, I'm good, how about you? Merin is here, we have Pritesh, Dharmesh, Chitra, Pritesh, Amit Kumar, Binit, Shamoon Azam is giving a thumbs up. Yes, Surya Pratap, perfectly audible. All right. Harvis, I'm good Harvis, thanks for asking. How about you? Okay, we have Ankit here. Sushmita says perfectly visible and audible. Sri Teja, Isha Roy, Tasin, yes. All right, so there is no glitch at all. That means we can continue. So my name is Khushbu and a very warm welcome to the first math session of grade 8. So today's session is a bit different because today we will actually be visualizing solid shapes, right? And also we will be doing some mind maps so that you get a better understanding and for the easy flow of the chapter. So are you all ready for this? Quickly, Tasin says very excited for today's session. Yes, I'm excited too, Tasin. Yes, Chitra Moni is giving smileys. Yes. All right. All right, so without wasting any more time here, let's start the session. So let's first start with visualizing the solid shapes that we see around us, right? So let's view some shapes and their 3D presence around us, and then you will tell me that you have observed those shapes around you or not. So like we can see here, we have a bat and ball over here, right? And this is a water bottle and the third one is a sofa. Now I'm sure that all of you must have observed these figures, these objects around you, right? All right. Now let's move further on our mind map and see what next do we have. So we have 3 dimensions now. Now we have seen the different 3D objects around us, right? Now let's understand first what is 3D actually and why they are called solid shapes. So let's go to a park along with a box of toys. Now let's make a tower of blocks using these 3D blocks. But I have a question, what is 3D actually? Well, a 3D, it's basically a 3-dimensional shape that can be defined as a solid figure or an object or a shape that has 3 dimensions, that is length, width and height. So unlike 2 dimensions, 3-dimensional shapes will have thickness or you can say depth as well. So let's visualize this on this cube. So you can see that this cube has got width, this has got height and this has got length as well, right? Okay, so now that we understand 3D, let's make a tower using these 3D blocks then. Now when we understand 3D, one question that comes to our mind is why is it called solid shapes? So everything around us that we can touch or we can hold, just like all the toys, these blocks, this ball, this pole, this bench, these trees, all of them are solid figures or you can say 3D figures, right? So now that we have understood what 3D is and why they are called solid figures, let's move further on our mind map and let's see what do we have next. Now we are going to see the formation of 3D from 2D. Adhira, ma'am, what are polyhedrons? Don't worry Adhira, we will come to this. Yes, we have this in today's session. Alright. So we have seen that, we have understood what 3D is, why they are called solid shapes, right? Now, let's first talk about the dimensions, right? And how these figures are formed. Let's first start with 0 dimension. 0 dimension, or you can say it's a point. Like A and B over here, you can see on the screen. They are nothing but they are points actually. So a point, I would say, it has no dimension. It has no length, it has no breadth or no thickness, right? It has position only. So this is called 0 dimension. Now, what comes after 0? Obviously, you would say it's 1, right? So now we will see what 1-dimensional is. So if I join these 2 points A and B, it forms a line, right? So it has length AB now, so it has got length only. It has got no breadth and no thickness, or you can say no height. So we call it one dimensional. Okay, I can see many of you are asking for Menti today. See, in today's session we are not going to have Menti, but yes, surely we have something very interesting in this session as well. So please watch the entire session. Yes. So now we will move on to 2D, right? That means 2 dimension. So let's, A and B points already we have here. Let's take 2 more points, C and D. Now let's join this AB, B and C, C and D, and D and A, right? After joining this, we get a figure over here, right? Which has got a length AB and DC and breadth AD and BC, right? So this has got, I would say, length and breadth, but it has got no thickness. That means no depth or no height is here. So this figure that we have got, it's basically a 2-dimensional, a 2D figure, right? Now we will talk about 3D, right? So how can we add one dimension to 2D to make it 3D? How can we do so? Let's take a 2D figure, right? Like we have this rectangle. If I keep piling up the same, the rectangle of same measurements on top of one another so that it reaches a certain height, what do we get at the end? We can see that it becomes a 3D figure, it becomes a cuboid over here. So this is the difference between a 2D and a 3D. We can see that when a figure is converted from 2D to 3D, one more dimension is added to it, right? It has got length, it has got width, and it has height as well. So this is 3-dimensional, since it has length, breadth as well as height. So that we get volume, Chandrakanta. Yes, once it is 3D, we can get the volume as well, definitely. Amit, it's blur. Amit, please refresh your screen once. Okay. So till now we have seen the formation of 3D model, right? Now let's try out the formation. Let's try to convert all the 2D figures to 3D, right? So let's take all the 2D figures. Let's suppose we have this rectangle here. If I keep piling up rectangles of the same measurement on this one on top of each other like this, so that it reaches a certain height, what it becomes? It becomes a cuboid, right? So you see, a 2-dimensional rectangle converts into a 3-dimensional cuboid. Ajay Kumar Singh, Byju's is best. Thank you, Ajay. So this becomes here rectangle, this converts to a cuboid now, right? Let me show you one more example. Like we have this circle. If I keep piling up circles of the same radius on top of each other so that it reaches a certain height, we can see finally that it becomes a cylinder, right? So here the circle is converted to cylinder, right? Circle is a 2-dimensional figure and cylinder is 3-dimensional. We have our next example, that we have a triangle. If I keep piling up triangles of same measurement on top of each other, what do we get at the end? We get prism. So triangle over here is converted into a 3-dimensional prism. Adhira, ma'am, your teaching is amazing. Thank you, Adhira. Dyudhi, thanks a lot for teaching. Byju's is my best friend. Wow, amazing. Thank you, Dyudhi. Alright, Shamoon Azam, very informative. I'm glad that you found it informative, Shamoon. Alright, so let's move ahead and let's see what do we have next on our mind map. So next we have different views of these solid shapes that we saw. Okay, let's take the example of this hut and let's see all the faces and the sides of this hut now. Okay, so you can see that here we have shown different faces of this hut, right? Now you have to identify all the faces of this hut and we have to fill up in these blanks. Okay, quickly I want each one of you to write the answers in the chat window. Alright, so let's start with the first one. This is the hut that we have, right? If you look at this, what does it look like? If you carefully observe this looks like the side face, right? So we will write here S-I-D-E, that's side face. Alright, now you tell me. Yes, Srinija has given the answer for the next one. Yes, what does it looks like? Yes, it looks like the top face. So this is top of this hut. Arya, Aditi. Okay, Adhira is saying first one is side view. Yes. Arya says it's top view. We are talking about the second one, right? Tasin has given the answers for all of them. Side, top, rear, side, bottom, front. Great. Wow. You guys are so smart and so fast, I must say. Okay, now the third one. Yes, this is we can see, if you see this face, this is the rear view of this hut, right? And Coming to the next one, this looks like the side face, right? And this is nothing, this is completely understandable that this is the bottom face and this is the front face. Yes. So all of you have given the correct answers for this. Amazing. So you have understood this clearly, right? How to identify the different faces of a figure. Absolutely. Okay, so how we see these faces of heart, or can we see all the faces at the same time? So to understand this, let's follow a bird named Birdie. Yes, and let's try to view things how she sees it. Okay, so she flew and now she's flying over the top of a bus, you can see, and where a man is approaching to catch the bus. Now can you guess how will the bus appear to the birdie and the man? So I want answers from all of you over here. Rumi Momin, East or West, Byju's is the best. It is helping me a lot. Thank you, Byju's. Thank you, Rumi. Okay. Now I want you to answer this. How will the bus appear to the birdie? Birdie is flying on the top of the bus. Sushmita, Sanpreet, okay, they have given the answers that she will be able to view the top view, right? She'll be able to see the top view of the bus. Absolutely. Chitra Moni, Shamoon, Aditi. Yes, Isha has given the answer for both of them. Adhira, Srinidha, yes. Sanpreet, Pritesh, Alok Tripathi, Ajay Kumar, Harvez, absolutely. She is able to see the top view of this bus, right? Now, how will the bus appear to the man who is approaching the bus? So, Colombo School, side view, yes. Shia, yes. Meenakshi says front view. Meenakshi, this is not the front view, this is the side view of the bus, right? So, Chitra Moni says yes, side. This is the side view for this bus. So, this tells us that how we see a figure actually. This means that it is based upon our position, where we are standing, from where we are actually seeing it, right? So, we are just able to see only one side at a time, that means. Absolutely. I can see the answers that all of you. So, Lakshana says side, Arya Patil, Melna, yes, Meenakshi, right, Alok, Aditi, absolutely, side view is the correct answer. So, you all have understood how to check the different views of a figure, right? Alright, now let's discuss about these different views. First one we can see here, this is the top view of this hut. So, what is the top view actually? It is the faces of a solid which are visible when viewed from the top. Right, this is what we saw when we were topping, when I showed you the view of the bus, right? Coming to the side view, it is the faces of a solid which are visible when viewed from a side, right? Because I just told you that from where we are actually standing, from where we are actually seeing it, right? That portion we are able to see of that particular figure. Okay. Front view, it is the faces of a solid which are visible when viewed from the front of that figure. So, this was about the different faces of a solid. Now, let's try out a few more questions so that we get a better understanding of it. So, a very interesting question is coming up. Identify the different views of this scooter. Now, quickly, I want answers from you. Chitra Moni, class is very interesting. Wow, thank you. Great. Okay, quickly, write your answers. You can see the images of this scooter from 3 different views. Yes. So, first one is, let's mark this as 1, 2, 3, right? Okay, Colombo School says this is the front view. Absolutely, this is the front view. Sanpreet says front view, right? Nivrati, front, and this is what? This is the side view, correct? Pushpa says this is side, Sanpreet says side, yes. Okay, you have given the answers for all of them. I can see mostly people are giving answers for all 3. Front, side and top, absolutely. This is the top view, correct. Pushpa, Aditi, Isha, Chandrakanta, Shrishti, Harvis, Ankit. Wow, amazing. You guys are really fast, I must say. Okay, so now we have understood how to check the different views, right? Let's try out one more question. So here we have to match the objects to their corresponding views. 3 objects you can see over here. We have a clock, we have a chair and we have a book. Different views have been shown here, right? Okay. Quickly, give me the answers for all of them. For the clock, Shamoon, thank you Byju's to bring informative videos. Thank you Shamoon. Okay. Ankit, copy is top. Okay, that notebook. Okay. Pritesh says clock is top. Clock is top. How come you see clock? If you see, it is from the front view. It is not the top view. Narayani, clock is front. Yes, this is the front view. So we can match here. Right. And chair is a side view. I can see answers from Sanpreet. Satya says front and then side, then top. Yes, chair. For chair is the side view, and for this notebook, for this book, it is the top view. Correct. Absolutely. So I can see that all of you have given the correct answer for this, right? So we have understood this very well. So now we know how to check the different views of figures very well, right? Quickly, just write in the chat window. Is it clear to all of you? Yes? I'm waiting for your answer. Chitra Moni is giving smileys and hearts. Yes, yes, yes. So I hope all of you have understood this. Is it crystal clear? Shamoon is giving thumbs up, saying yes, ma'am. Jitendra says yes, ma'am. Sapna, Pritesh, yes. Chandrakanta, Aditi. All right. Yes, Pritesh says yes, ma'am. Isha Roy, got it, ma'am. Chitra Moni, clear with hearts. Cool. I can see lots of smileys. Super clear. Got it, ma'am. Great. So we have understood it, but something very interesting is coming up now. So it's basically an interactive learning element. All right. So let me show you. All right. Okay. So here what you can see is, you can see change the direction of the torch and observe the shadows that are being cast by the object. So here you can see this object over here on your screen, and you can see the torch. So I'm going to show you the different views over here, right, of the shadow that it's making. So top view you can see here. Now you can see here the side view, right? So the shadow being cast in this orientation is same as one in the top view, right? Now let me show you the front view now. This is the shadow of the front view. So the shadow being cast in this orientation is different from the shadow cast in top and the side view, right? So from front view and side view, from top view and side view, it will look same. From front view, it is different, right? Now I have a question for you that you need to try. So you can see an object over here. Which of the following shadow is cast by the object if the light is incident from the top? So this is the object that we have. If the light is incident from the top, so which will be the correct shadow of this? So you have 4 options over here, right? And you need to choose the correct answer from this. Quickly. You can give your answers in the chat window. You can write on 1, 2, 3, 4, whatever the correct answer is. Srinija says it's the first one. Isha says figure A. Ritu says it's A. Shamoon, A, ma'am. Colombo School, first image. Ajay Kumar Singh, first. Ritu's imaginative corner, it's 1. Akarshan, it's 1. Ritu, 1. Sapna, option A. Harvis, A. Narayani, Krish. All right. Okay, let me show you what the correct answer is. Yes, absolutely. Option A is the correct answer for this question. Alright, so all of you have given the right answer for this. So just like this, something very interesting you can try after the class, and the link for that is given in the description of the description below. Alright, so let's get back to the normal session. Okay. Alright, so let's move ahead. So till now we learned about the different 3D objects around us. We learned what is 3D. We learned about the formation of 3D from 2D, and also we learned about the different views of figures, right? Now let's move on with our mind map and see what comes next. So now we will be talking about the faces, vertices and edges, right? Alright. Manimala ji, what about the sessions for class 9, ma'am? I haven't found anything. Well, Manimala, don't worry about it. For class 9 session, please subscribe the channel, I would say, and you will get notified about the upcoming sessions. All right. Okay, so now we will be talking about faces, vertices and edges. All right, so in the last section, we saw the different views of 3D figures, right? In this section, we'll be understanding the faces, vertices and edges of all the 3D models that we have, like this cuboid, this cube, this cylinder, this cone and this sphere. So one by one, we will understand them. But first, we will talk about what faces, edges and vertices are. Yes, Isha, what is Euler? Don't worry, Isha, I'll come to this. We have this also in today's session. All right, okay. Let's first understand what is a face actually. So a face is a flat surface of a solid. Like in this picture over here, you can see this cube. So you can see the 6 flat surfaces of this cube. So so we can say that there are 6 faces of a cube, right? Yes. Shia, if you want to understand anything, just move to Byju's. Thank you, Shia. Master of learning, Byju's is like a Superman, always rescue me from trouble. Wow, thank you. All right, now let's see what edges are. So edges, if you see this cube, edge is basically a line segment where 2 faces of a solid are meeting. Like you can see here, can you see this red line moving over here? So what we see here is that where every 2 faces are meeting, right, that line segment, right, that's called the edge. Navrati, Byju's is doing a fantabulous job providing us with amazing classes. Thank you, Navrati. Thanks a lot. So, if I count here, there are total 12 edges of this cube. Correct? Right? Now, let's see what vertices are. So, vertex is a point where 3 or more edges of a solid are meeting, right? You can see this red dot which is moving, right? So, wherever you can see this red dot, this is nothing but these are the vertices. If you count them, there are 8 vertices in a cube. Right? Okay. All right. Now, let's count the faces, vertices and edges of all these figures and we have to fill this table. Quickly, I want you to answer here. Right? Okay. So, first we have this cube. What are the number of faces of this cube? Quickly, number of faces in a cube are, we just understood what faces are, what edges are and what are vertices. Nidhi, twinkle, twinkle, little star, Byju's is superstar. Thank you. Thank you, Nidhi. Yes, I can see a lot of answers and all of you are giving the right answer. Number of faces are 6. What about the edges? How many edges are there in a cube? Yes, Srishti, Sushmita, Loshini, Divansh, Ardra, Aditi, Sanpreet, Krish Kunal. Yes, absolutely, it is 6. There are 6 faces. Yes, 12. Sanpreet, Vinith, Chandrakanta, Isha. Yes. Yes, Ankit. Pritesh, yes, number of edges are 12. Sangeeta, Byju's class 8, 9, 10, one-stop destination for all our doubts and clarifications. Yes, indeed, all your doubts and whatever confusions you have, that will be clarified here. Number of vertices, yes, I can see answers here. Umar Anis says it's 8, number of vertices are 8, right. Next we have our second figure. How many faces do we have here? In this figure, if I count the faces, so in all we have got 5 faces, right. Quickly, I want answers from all of you. Then number of edges if you count here, where 2 faces are meeting, number of edges are, that would be 8 over here. Yes, I can see the answers. Ajay says 5, right, Shamun says 5. Okay, you can giving the answers of the number of faces. Okay, edges and vertices. What about edges and vertices? Edges are 8, yes. A as bagel, yes. Absolutely. Umar says 5, 8 and 5. Yes, Umar. Number of vertices over here are also 5. These are the vertices, right? These are the vertices. Cool. Now, we have our third figure over here. Number of faces, edges and vertices. Quickly. Number of faces would be, if you count here, number of faces over here are 6. Very simple question, right? Chandrakanta, yes. Pritesh says it's 6. Correct. So, faces are 6 and what about the edges? Edges over here are going to be 12 and number of vertices over here, these are the vertices, right? So, number of vertices over here are 8. Correct. Yes, Krish says edges are 12, right? Alright, so we have understood how to check the faces, edges and vertices, right, of the 3D figures. Alright, now let's move ahead on our mind map and see what do we have next. So now we will be talking about polyhedrons. I remember in the beginning of the session somebody was asking me, ma'am, what are polyhedrons? So now the time has come, now we are going to discuss that. So let's first understand what polyhedrons are. It's basically a three-dimensional shape that has flat faces, straight edges or sharp corners, which you call them vertices, right? And very interesting thing that the word polyhedron has come from classical Greek word where poly means many, right? And poly means many and hedron means faces, right? A three-dimensional figure that has many faces, right? But it will have flat faces and you can see these examples over here, right? Is this session about to end? No, Umar, there are still a lot to cover and whatever you have missed, you can watch the recorded session on YouTube, right? Alright, I joined late, that's okay, no worries. So these are the three examples of polyhedrons, right? Okay, now we will talk about non-polyhedrons. So basically non-polyhedrons are the solids with curved faces. This is the main keyword over here. They will have curved faces like a cylinder, like a sphere or you can say a cone. They are called non-polyhedrons, right? Alright, so this was about polyhedrons over here. Now let's move on with our mind map and let's see the types of polyhedrons. Okay, so these are the different types of polyhedrons that we have. So we have first convex polyhedron, regular polyhedron, then we have prisms and then we have pyramids. So I'll be discussing each one of them one by one. Umar Anis, Euler's formula, we haven't discussed that yet. Wait, we will be discussing that, don't worry. Okay, alright. Now, we will talk about convex polyhedron first. So what is a convex polyhedron? So basically a line segment joining any 2 points on the surface of a polyhedron, right? Entirely lies inside or on the shape. This is the important keyword over here. So those line segments should lie either inside or they will be on the shape. So this cube over here is an example of convex polyhedron, right? Yes, Umar Anis, interesting, right? Okay, now this is another example. This is your cuboid. This is another example of convex polyhedron, right? Now we will talk about regular polyhedron. Okay, so what is a regular polyhedron? A polyhedron is said to be regular if its faces are made up of regular polygons. By regular polygons means they will have the side lengths would be equal, right? And the same number of faces would meet at each vertex, right? Vijay Kumar, top to bottom, Byju's make everything covered. Thank you. Alright, so this is a regular polyhedron. Two things you have to remember, that every face will be made up of regular polygons and same faces, same number of faces will meet at each vertex. So this is the example for this. Now let's talk about prism. So prism is basically a polyhedron whose base and top are congruent polygons, right? Like you can see here, and whose other faces, these two faces that you can see here, these lateral faces will be parallelograms. These are called prisms. Shravya, thank you ma'am for clearing the concepts. I have understood till now. Thank you, Shravya. Yes, okay. So this is a prism now. Now let's move ahead and we will talk about a pyramid. So what is a pyramid actually? It's basically a polyhedron whose base will be a polygon, right? And it can have any number of sides. I'm talking about the base of the pyramid. It will have any number of sides, but the lateral faces will be triangles, right? You can see all the faces here, right? They are triangles and they're meeting at a common vertex. They all will have a common vertex. Alright, so that's a pyramid over here. Alright, so this was about the different types of polyhedrons. Now let's move ahead and see what do we have next. Yes, now comes the Euler's formula that you have been asking for, right? Srinija has been writing the Euler's formula for quite some time now. I could see that in the chat. Yes. Sapna, Byju's best learning app of India. Thank you, Sapna. Okay. So to talk about the Euler's formula, first we are aware about the 3D shapes, we are aware of their faces, vertices, their edges. We know how to count them, right? So now a question for you. Can you tell me the number of edges in this figure? Quickly. Quickly, I want your answers. Yes. Krish, ma'am, can class 8 also have something like quiz time? Don't worry, we will come up with something like this. Don't worry about that. Yes. Number of edges, Chandrakanta says it's 12. Yes. Pritesh, learn with Aryan, Jitender, Sulakshana, Shravya, Devesh, Devansh, Aditi, Isha. Yes. Oh, I can see that mostly all of you have given the right answer. It's 12. Some are writing 8 also. How come the edges are 8? These are the edges, right? You have to count them. To count these lines over here where the faces are meeting. They will be 12. 12 edges are here, right? So this was simple to count because it was a very simple figure, right? It was a cuboid. Now what about this one? Can you count the number of edges in this figure? You would say yes, we can count, but it's going to be time consuming, right? It's going to be a little difficult. So for such things, for such figures, we have Euler's formula. So basically a Swiss mathematician named Leonhard Euler, he actually discovered this. So he observed the relationship between the faces, vertices and edges and all the polyhedrons. And so let's check out his observation first. So according to his observation, if you talk about a cube, its number of faces are 6, edges and 12, vertices are 8. So he says that for every polyhedron, faces plus vertices minus edges will be equal to 2. It's applicable for all the polyhedrons, right? Yes, Ankit. Yes, obviously, because without this formula, it would have been very difficult for us. Now let's try out for this pyramid. Here faces are 5, number of edges are 8, vertices are 5. So Euler's formula fits here as well. It says faces plus vertices minus edges would give us 2. Similarly for this cuboid as well, if you check it, again we get 2, right? So on rearranging it, he says faces plus vertices minus edges would be equal to 2, and this is basically the Euler's formula that he gave, right? So this is the formula that we have at the end. So using this formula, we can actually find out, like let's suppose 2 things are given to you, you have to find out one missing thing from here. You can find it out using this formula because it's applicable for all the polyhedrons. All right. Now let's try out a few questions so that we get a better understanding. Find the number of edges of a figure that has 8 vertices and 11 faces. So finding the edges without a figure, how do we do that? So without this Euler's formula, it wouldn't have been possible for us, but now we can do it with the help of this formula, right? So this is the formula that we have. Faces are 11, vertices are 8. Just substitute here. What do we get? We get 19 equal to edges plus 2. So 19 is equal to edges plus 2. So edges would be equal to 17 over here. That's the right answer. Isha Roy says 16. How come it is 16? Soham says 21. Some are saying 16, some are saying 17, some says 21. 17 is the answer. How come you are getting 16 and 21? कैसे आ रहा है ये? Please check your answer. Now Isha is saying it's 17, right? Soham says 21. How come you are getting 21 here? Okay, now I can see 17, 17, 17. Yes, 17 is the correct answer. All right. So this was about Euler's formula. Now let's move on to our mind map. So till here we have completed the entire part of 3 dimensions which contains different sections. So let's move on and try to understand mapping. Very interesting topic. Alright, so let's play a memory game. See the picture of a room, right, and memorize it. Why I'm asking you to memorize it? Because now I'm going to ask you a few questions based on this, right? Ma'am, can you let us know which chapter for grade 8 you will be taking next? Shravya, I would suggest that please subscribe the channel and hit the bell icon. You will get notifications about what the next session would be. Alright, so I think that all of you have seen this picture clearly, right? Alright, so I'm going to ask you a few questions. So after entering the room, my first question is, what is opposite to the door? Yes. So once you enter the room, what is the thing that is right opposite to that door? Quickly, I want answers. You can write in the comment section. Okay, many people are saying window. Yes, Shamoon says window, Zarina says TV, Vinit says window, window. Srihari says wall. Okay, so mostly people are saying it's window, right? Correct, window is the right answer. That once you enter the room, the thing that is opposite to the door that's the window. Next question. In which direction will you move to get to the TV? Quickly, think about it. So which direction should you move so that you get to the TV? All of you, give your answers here. I can still see the answers of the previous question. Can we have more comments, please? Yes. Umar Anis, left. Isha, Sapna. Okay. Vineet says left. Maria says left. Adra says left. Sashmita. Yes. Sanpreet. Right. 5-star class. Okay. Harvis, Krish. Okay. Yes. So we have to move to the left to get to the TV. Another question. In which direction will you move to sit on the sofa? Quickly. Yes. To move to the sofa, in which direction would you move? Chitra, is my chat visible, guys? Yes, absolutely, Chitra. Chandrakanta, right. Harvis, right. Krish, right. Ankit, right. Ardura, right. Isha, okay, right. You were basically writing right. Archit, yes. So you have to move to the right to sit on the sofa. So basically, most of you were able to give the answer correctly. But how? It's not that the picture was in front of you while you were answering. See, it's because when you saw the pic, you did a mapping of it in your mind, right? That's why you were able to answer the questions correctly. So it is same as, let's suppose you leave from your home to meet your friends outside your school, and because you have been going to your school for quite a while, so you know the directions, right? You know the path. So you have a mind, you have a map of it in your mind that how to reach to your school, right? So you go from here, you move to this direction, right? Then you go straight, and then you move here, and then you meet your friends finally. So you were able to reach out to your friends just because you had a mapping in your mind of the path that you had to follow to reach them, right? So this was about mapping. Now next we have is scaling. This is also very interesting topic. So let's understand what scaling is. So now we know what is mapping and what a map is, right? So let's look at the map of India, how it looks like on the mobile. So do you really think that India would actually be so small as it is looking on this mobile screen? No, right? So let's zoom into Karnataka and see how it looks like on the mobile screen. So definitely it will be smaller than India, right? Than the map of India on the mobile. Let's check this out. Okay, so we can see that it is of the same size as of India on mobile, right? But definitely Karnataka would also not be that much smaller in reality as it is looking on the screen. So we can see both the maps of Karnataka as well as India on the 5x7 mobile screen. But how? That's because of scaling, right? Because a map scale is the relationship between the distance of a map, right? Distance on a map and the corresponding distance of that thing on the earth. Let me show you an example here. So let's try out this question to understand this. Yes, Pritesh, map scale, right? Yes. Okay. Using the scale, find the distance between Catherine's house and David's house. This is Kathy's house, this is David's house. So using the scale, we have to find out the distance. Here 1 centimeter is equals to 150 meters. Now we know one thing. That total distance, if you count from here, this is 3 centimeter, this is 3 centimeter, and this is 2 centimeter. If I add them up, I get 8 centimeters. That's the total distance which I can see on this map, on this scale over here, right? but actual distance 1 centimeter is actually equals to 150 meters, right? So original distance would be 8 times 150, that would be equals to 1200 meters. That's the original distance, right? See the actual distance and the original distance, the actual distance and the original distance that you, the distance that you see on the maps and the actual distance, they're always different, right? So this is what scaling tells us, right? Yes, Isha, 1200 meter. Shravya has converted that into kilometers, that's okay. Pritesh, 1200 meters. Ardura, right. Umar Anis, okay, kilometers, fine. Beneath, Ardura, Nidhi, 12 meters. How come it is 12 meters, Nidhi? Sulakshana, 1200. Ankit, chapters are difficult, but Byju's make it easy. Thank you, Byju's. Thank you, Ankit. I'm glad that you actually liking it. Okay, Krish, 1200 meters, Harbis. Absolutely, this is the right answer. Alright, so this was about scaling and this was the last topic of today's session. But don't worry, we have got you covered and we have lined up many more sessions for you from every Monday to Friday to make you exam ready. So please stay tuned. And let me give you a glimpse of what all sessions are there in the waiting list. So we have our next session on Master Everything on Combustion, which is on January 6th, that is Thursday, 4 p.m. is the class timing. And if you want to have access to more such great content, then please click on the link in the description below and you can get all your doubts clarified instantly during the class. And I hope that you enjoyed this class today because I really enjoyed teaching you guys. Harvey says Byju's is awesome. Thank you. Chitra Moni, thank you so much, ma'am. Yes. Vijay Kumar, thank you, ma'am. Yes. Harvey, Byju's is awesome. I can see that written so many times. Umar Anis, bye ma'am, have a nice day. Thank you, you have a nice day too. Alright, Shravya, thank you ma'am for the amazing session. Alright guys, so it's time to bid farewell to you guys. I'll see you soon. Till then, be curious, keep learning. Thank you.